Swayam Prabha. Digital India. Educated India.
Hello everyone. In this lecture we will discuss about climate responsiveness. So in the previous lecture we studied and we discussed the vernacular architecture. So the strongest feature of vernacular architecture is the relationship with the climate. Okay, so how this strategy of climate responsiveness has actually worked wonder for the architectural systems from across the different actually places, and so we will see actually those things, and we will try deciphering some more finer climatic responsiveness strategies which are very important for design. So if you see the simple definition of a climate, so what is a climate? So climate is a actually longer period of maybe a prevailing actually environmental actually conditions, okay, which are imposed by the nature, okay, on any a given place. So it has to do with the this weather pattern, so that weather pattern which lasts for a longer period of time, and that actually longer period usually we take it in a cycle of 1 year. So that thing that actually natural actually occurrence of these prevailing actually atmospheric and environmental conditions, collectively we know them as the climate. And what is responsiveness? So responsiveness very simple, is the answer to that given situations. So when we see so this is the climate, and these are it's elements of this climate. Okay, so the climate is a long term actually record and trend of the different averages of these actually elements of climate and weather which happens on the day-to-day basis. So whether, for example, if it is a rainy day or a cloudy day, so that's as a resultant of weather. But if the several months are going to be a sunny or rainy, or very cold or chilly or snowy, so that because of the climate. So the climate actually runs on the planet on an annual basis, and weather we have on on the daily basis. So you can see the elements of climate. So that is the sun, the winds, the humidity, the temperature, the precipitation. So collectively these are the actually elements, and in a combination of these elements a climate is actually constituted. So a typical if you see a climate chart for any city, this is example I have taken from the city of Hyderabad in India. So in this chart actually you can see the average actually daily mean temperature in centigrades. You can see average high, okay, in the different months, the record high which has happened in this plane, okay, in this plane. So this data is from a year of 1981 till 2010, and the average low in centigrade and record low. Okay, so this is about the temperature, and the next the average rainfalls in millimeters. Okay, so how much of rainfall this place has actually received in these many years. So there is an average given. Okay, and the number of rainy days per year, how many days are rainy. Okay, and then average relative humidity RH. Okay, so that is average actually taken off these all of these 12 months. And then there is a mean monthly sunshine hours, and then mean daily sunshine hours. So yeah, so with this you can understand, it is very evident from here, most of these months from this place Hyderabad, they are in the warmer areas. They are either red, dark red, or oranges, and then yellows. Very few days are close to whites, or close to a cream. So that means this place has actually a majority of it in a warmer side and the hotter side only. With the extreme temperatures you can see over the years which has been recorded over years is 45.9 degrees centigrade. Okay, and in the months if you see June is considered to be one of the hottest ones. Okay, with the average actually record high of 45.5, and then the daily mean in of 29.7 degrees centigrade. Okay, the lowest temperature which was recorded over here is 6.1. okay, and that has I think recorded in the month of January. Okay, so this is the actually distribution of there's a temperature in these many months, and if you see the rainfall, well, August is supposed to be one of the wettiest month with the 207 actually millimeters of rainfall in this month, and other months, for example, like January, December, February, March, these are relatively actually drier months, so very minimal actually precipitation, and it is rainy days. Okay, so here in the month of like August, 11.5 days are rainy days. Okay, and relative humidity also has increased in those months of the like monsoon, and with the 69 actually percentage. Okay, so this is actually overall. So this chart you can source for like any city wherever you are living, and you can just have a look at it, this chart, to understand the what kind of a climate you are living in. So this will give you some ideas like the how much is the like average actually temperature, how much is the average like a relative humidity, how much is the like volume, how much is the like volume of rain this place is going to receive, because these are the actually major constituents of climate. Okay, so you can easily understand what kind of climate you are living in, and how much, like up to what extent it is affecting like your comfort level and your well-being at that place. So accordingly you can engineer all your designs, all your like actually responses. So the responses which you will frame for your design for this particular place, they will be known as the climatic responses. Okay, and these are very important actually for like a design considerations. So let's move ahead. So when we talk about like a actually surface area compared to the volume, so if we take a surface of like a square, in the massing chapter we have seen, if we take a cube with one unit volume and one unit surface area, so if we start disintegrating into like while increasing the surface area of that actually volume, or maybe reducing the surface area in the given volume, so how much of actually the energy requirements will increase by increasing the surface area. Since the surface area will increase, the exposure to the sun will also increase in the same actually proportion, right? So if the sun exposure, the sun gain is actually will increase, the heat load on the building will increase. Okay, so if you want that actually heat load, for example, if you are living in like a climatic like a colder places, then it is ideal for you to increase the surface area. But if you are not living in like a colder places, you are rather living in a very hotter places, then it is always desirable and recommended to go for actually minimizing the surface area, so that reducing the heat gain in the blending. So in turn you will be spending a little or in a controlled manner for actually cooling that actually space. So with the area actually given over here, if a square is like a base case which has like a 1 unit surface area or 1 unit of volume, then a circle, okay, would be even having like a smaller surface area up to like a 0.88. Okay, and this will be the most efficient actually geometrical actually geometry to minimize the actually the sun exposure. And similarly you can see in the other like rectangle L and H actually forms. So the component of this exposed actually surface area is increasing, so increasing actually over in overall actually change the heat exchange of these geometries. So how this is used in the several like places in the several actually countries, in what ways? So we will discuss with the help of some case examples. So in this structure, if you see, this is the first actually illustrated cavity brick wall which was found in the country of like Britain, and it the cavity wall is actually kept to keep the groundwater away from the ice. Okay, so this is the actually approach which has been used in this design over here. So you can see like how this is passing from actually the external actually side of it. Further to this, I think this is a very known graphic or illustration for us. You may have seen it already like n number of times. So if you see like how the Havelis in Jaisalmer, India have been like designed. So this is taken from like Matthews 2000. Okay, so this side is the north and this side actually is south. So the how the sun load from the south, starts heating the building. So the first exposed quarter of this building falls is here on this top right corner. So it gets actually heated in like 1 hour 35 minutes time, and this heating of this bulk, actually this entire actually structure, starts happening from like this side, and it keeps pushing on the on the lateral this side, as well towards like a ground floor, and it takes like the different quarters. Actually it has been analyzed and given over here, like how much of a time in the time actually factor is needed to heat up actually these areas. Okay, so this shows actually this time lag from here, from this quarter to the next quarter. It is required to have like spend 25 hours 5 minutes. Okay, so this actually portion will heat up from the like outdoor actually lighting condition. Okay, and similarly like on this side, it will take like a 2 hour 49 minutes, and on the bottom actually most left side, if you see, it will take 2.4 days to hit up actually this area. So obviously if you see this entire actually cross section, has actually several advantages in terms of its length and breadth, how this building should be of like this x length and y height, in order to create some habitable quarters, which can be utilized in the like one of the hottest months of India in this particular place, because Jaisalmer falls in one of the hottest areas, hottest regions of the world. Okay, and the temperature sometimes in the summer reaches to the like extreme. Further, if you see like how this tribe in Iran has evolved these methodologies of like using like a different materials, in the different cross section, in the different like a fashion. You see this is a rollable actually mat of these actually grass and other material, which works as a insulator actually element for covering this building structure. In this example, you can see this is the typical cross section of an like a igloo. Okay, so we are all fascinated with the design and the structure of the igloo since our like a childhood, and we have like a scene like how the people in this like regions, one of the harshest cold climatic regions in the world, they actually survive the harshest actually winters and the cold actually prevailing winds, and this climate actually, which is extreme. So this form of this structure, which is made up of the ice itself, the frozen actually water, to create actually habitable chambers within this actually shell over here. So this follows the semicircular actually structure. So this cross section shows this thermal stratification above this actually raised platform over here. You can see how the temperature is actually varying, in this like a huge actually number. From here in this chamber it is minus 15 degrees centigrade, and here it is 0, and here it is plus 20. So this is a significant actually change in the like a comfort from this chamber to this chamber over here. And this is how actually they have laid down the internal arrangement of this structure. So this is one of the actually marvelous vernacular architectural systems which has been used by humans in these like extreme inhospitable actually cold climatic regions for like several years now. Okay, further we will see like how the material actually plays an important role in getting the desired results which we want actually from our like structure. And this has been a very key actually element, key actually slide for us to understand like how we can play with the materials in like designing our structures in a like a vernacular way. So if you see, this is the embodied energy actually consumed by different materials. So if you see the natural aggregates, the very natural like materials, they utilize the lowest of the lowest, less than like a 1 actually gigajoule actually per cubic meter, and if you see like the cement and the bricks, they are like using like 11.7 to like a 16 gigajoule per cubic meter, and the timber actually takes only 3.6. This glass takes around 81, and the highest is taken by the steel, which is like a 460 gigajoules per cubic meter. So that much of like energy is required to actually produce 1 cubic meter of steel. So we can see if we compare, so this first value is less than 1 and this value is like a 460. So there is an immense actually difference between like this to this. So just imagine like in the like a previous lectures we were discussing like how the world as a whole has fallen in the trap of actually consuming tremendous volume of like energy, and how this dependence on energy can be minimized through adopting these strategies. So the answer is right there. Choose actually the materials responsibly which are going to behave in certain ways. So even if we are constructing modern buildings, so we should not actually forget these buildings which are very very earthen, very very rooted to a place. So we must actually utilize them, and we can explore different ways of adopting them into our like a modern building. So that is the one of the challenge, and very I feel very challenged to use evolving actually innovative ways and strategies to adopt these low embodied energy materials in utilizing our like a modern houses. So how this can be done is I leave it to you. You can utilize these actually lessons from this lecture, from this course, and utilize in your like design projects and exercises. How well or how efficient you can make them by just changing, for example, just the material part of it. So instead of like using bricks, so if you use like a adobe based like a bricks or rammed earth bricks, so how much of energy you can save, how much of embodied energy you can save right there. And by avoiding actually steel as much as possible, just keeping steel for the like a structural purposes only, like how much we can make we can actually bring the difference. So the answer is right here in this actually data sheet over here, and the interpretations are like up to you to take it ahead. So another example in like a very inhospitable actually environments of like Antarctica, how scientists and explorers they have actually created and designed the modules and the maintainer actually pods to survive this in extreme inhospitable environment. So you can see there are like several chambers. So this concept is also derived from the igloo what we saw in the like a previous slide over here. To have like a sections, have the chambers, the multi-layered chambers in the spaces, so you can see this chamber actually, this is for like a entrance, ablutions, ice melting, heavy class equipment, thermal buffers are in the this zone A. In the zone B, there is like a gallery and the wet area and the workshops, and then in the chamber C there are like a communications, eating, communal, sleeping, etc. These activities are here in the innermost actually chamber area. So this is the actually modern derivative of the same philosophy and the same approach which has been used in the vernacular like a system of like such places. Okay. Further on the material part, coming down to the material fall, if you see the relative density, conductivity, and thermal capacity of the range of materials. So three things we are talking about here, and this is also one of the most important actually charts and tables for us to like be aware of the kind of materials what we are choosing, and how much of impact these are going to have on our like designs. So how much of a material they are going to use, how much of energy they are going to use, so by choosing appropriately we can control the wastage of the resources as well as energy. So in the thermal capacity, if you see, the lead has the lowest 126, and if you see this the water has the highest actually thermal actually capacity to retain the actually heat. So how the water can be utilized as like a maybe packets and the layers to work as a like a buffer between interiors to the exteriors. So this interpretation is up to you. Some other like very familiar like materials, you can see the brick consumes like a 800, almost like a glass has like 840, and then we have like a cork as in like insulating material has like a 1800 compared to the best actually man-made material, or the cork is also a natural material but adopted by humans for like a certain uses. So compared to even like this kind of material, you see like how much of a plain water has almost the double of this the cork, even more than double of it. Okay, so this is actually kind of a potential these natural actually material has. So if what if we use water as a material, for like a creating like a thermal capacity in the like structures, in case of like for example, if you want to reduce the heat quotient of our building, so how efficiently we can utilize the water itself, as a like a one material. Okay, so further come to the like a conductivity column over here. So well, lead has the highest conductivity, and one of the highest, and you see that the most highest actually we can see here lies in the brick, and this is the region actually this brick material, okay, gets heated very fast, and it absorbs the heat very fast. And you compare to this, you see all of these like materials which are actually sourced from like water, nature, whether it is like water, cork, or these timber software, they are all they have actually this conductivity quotient in like a fraction. Okay, so well, we can choose like a proper combination of like these three actually values, and we can apply these materials responsibly. Further to this, what could be the other strategies? So ventilation is one of the very important actually requirements of like any building. So how we can plan the openings in our building, okay, because there is always like a some wind. So how we can even if it is not the wind is not very fast, so how we can create actually high pressure and low pressure actually micro zones to induce the wind inside our like a premises. So this actually slide talks about that. So how we can promote actually cross ventilations, and how we can promote a staggered actually way of like a wind movement, in case if it is not needed, then how we can avoid it, so the with the in the direction of like a prevailing wind, we can place our building in such a way that it doesn't actually receives like so much of air, if we want to avoid it. And similarly, if we want to like receive wind in the like interior quarters, then we can position our building, we can position our openings in such a way that we can take the most advantage of it. Further to this, we will see like this slide over here. So this talks about controlling the temperatures and humidity inside the premises of any given building. So this example we saw in one of the pictures in the vernacular actually lecture. So we saw these wind towers. Okay, so these wind towers, the main function of these wind towers is to receive the wind, bring it down in the like lower quarters of the building, and while actually going below the actually building in the lower quarters, this air actually gets in touch with the colder actually wall surfaces, and even sometimes like the water element which is flowing below the building, and then again it rises, cooling the actually temperature in the like other quarters of the building. So this is one of the very actually interesting actually techniques which has been popular in the several like vernacular architectural systems from across the world. Even India had like some of these examples from like a dry and arid regions, and several such examples are found from like the other actually hot and dry regions from like a Gulf area and other countries. So these are called actually wind catchers, sometimes they are called like a breeze walls, so this is the actually phenomena how they actually work. Further continuing our like a previous discussion, so in the cross section also we can plan like our openings in such a way like the one we saw in this like a wind actually tunnel wind breeze wall actually in this cross section. So similarly we can actually have, even if we are not going to have actually very tall structures, so how we can actually plan the openings, the cross section of these openings, the length and width of these openings, we can actually make them vary, and depending upon that we can control the passage of wind through the like premises. Okay, there are several other like there's a passive solar actually systems mechanisms which employ actually the the specific materials which we saw in the previous slide of embodied energy, and even like the conductivity, like how much of the heat they are going to transfer to the like internal quarters. So depending upon this property, we utilize these materials in different combination, whether like how much of like a heat we want to allow in the interiors actually of that space, and how much we do not want to. So it's a combination of actually different materials in like a different like a cross section. You can see over here, this is known as like a typical like a typical actually passive system, where in some portions we are allowing the actually heat inside. You can see the material legend over here. This line represents glazing, and this represents insulation. This one like a thermal mass. Okay, these are blinds, this airflow and the thermal radiation. So you can see over here like this material of like a thermal mass is going to have some like a radiation actually inside the this quarter. So we can allow these like a such kind of like openings over here, which can penetrate inside the spaces. And similarly, you can see all of these examples, like how this heat and the conductivity can be controlled by applying like such materials. In this combination, you can see how the same actually cross section is going to be have in like on the day and night. So that is also illustrated over here. This is a rock bed actually charged from the sun space during the day, and this only heat passively discharged at the night from the rock bed. So this rock bed actually it absorbs heat in the daytime, it releases heat in the like a night time. So that there is a balance of temperature in the internal quarter. So this is one of the actually important actually slides where we talk about choosing strategies for like our designs. Further to this, in the wind driven like evaporating cooling this technique, there are some more examples in this area, even utilizing the vegetation, at what distance they should be, the what height of these trees should be to have a shading effect on the building, creating actually buffer zone of like a air, creating actually a cooler ambient temperature here on this in this vicinity. So utilizing actually the prevailing wind directions, in like a hot dry actually seasons. So these vertical screen actually towers, these wind tunnels actually work as like a evaporating actually units. Sometimes they actually use cuss linings also to create actually fragrance, a beautiful fragrance of this water, of this air inside these actually premises. Further, some recent in the recent times, in the recent like a few decades, there are some examples used by several like architects from this age, also utilizing the vernacular actually principles. So you can see by Ashok Lal how he has utilized these jali as a screen, as a like a filter actually, to reduce the temperature from outside to the indoor actually quarters. So obviously there will be some actually reduction in the temperature of the air while passing through this chamber. We can see here like some examples from like a different countries, like how the vernacular actually designs, they have been part of the nature itself. Okay, you can see over here this this actually doesn't looks like a man-made actually roof, but the natural actually glass surface has gone on top of these houses. And some more examples over here, you can see these like a Jain quarters from like Japan. Okay, and these are like a wooden and thatch roof, utilizing like the stone actually for like these retaining walls. You can hear, and these are structures which are carved out of like this stone blocks, so the rock cut architecture, and even they have utilized the stone and the other brick materials also in the along with this stone. So it is a combination of like a rock cut as well as like a man-made structures, and these are like a wind tunnels and wind actually towers. Okay, and in the recent times, if you see like how these adoptions have been like done, so utilizing like a mechanical methods, utilizing like a electricity based actually solutions to control actually temperature, control humidity, and the wind directions. So a combination of these, if you see like how the integral these examples are with the like a climate. So depending upon actually the need of the climate, so these arrangements are actually made to how we can harness the solar energy at these places where there is a plenty of like a solar exposure available around the year, and how we can go in the gel with the like a landscape and the topography, how we can go for like ventilation through these actually methods and mechanisms, and things like that. So some more strategies like how we can plan the openings, on the like building surfaces to restrict the summer duration like a sun which is very harsh and hot, and we can permit the winter duration sun inside so that we can get some warmth in the like a colder months. So such arrangements are very typical, very common. I'm sure you may be like already aware of like such strategies, but I'm reminding for our like understanding. And these small details also, like sometimes we keep forgetting, so these actually play a very important role in our like design and choosing like strategies. Other like dealing with the temperature changes, how we can create like a insulator, actually this surface insulating like a material on the envelope of our building to reduce the actually heat exchange. How we can plug the holes and gaps and the other leakage points to check the actually leakage or fuel. There are n number of like materials commercially available in the market today for like a thermal insulation, so we must choose them like depending upon the uses and application. And while doing so, we can actually minimize the consumption of energy. Further, sun gives us free light, free heat. So how well we can utilize, and in those months when we do not want, how well we can actually avoid it. So by choosing like a strategic actually methods. So you can see this is a chart, actually climatic chart of the city of like a Melbourne in Australia. So this gives a comprehensive picture of like a there's a like a temperature, monthly temperature over the year, and this talks about the solar actually exposure and the angle at which the sun is going to be in this particular place, and then the prevailing wind direction. So this chart you can prepare for your own city, or for own city also, your own town also. You can keep it handy for your like a design needs. Further, like there could be like several strategies, several actually responsive strategies for like a climate related actually responsiveness in an overall sense. So that could be depending upon the orientation, what we had discussed earlier, thermal mass based on the properties of the material, shading strategies, daylighting strategies, natural ventilation, water strategies, also like how water can be utilized in like creating actually ambient temperature inside the actually living quarters. So there is this like a comfort zone, human comfort zone. You may be aware of this Nani table. So maybe you can refer the Nani table of your own place, your own city, and you can look for the comfort zone, like what actually the set of the temperatures, what are the set of like a relative humidity and wind actually speeds are needed, and for like a comfortable creating a comfortable actually climatic condition for the humans, and accordingly you can actually employ. So this is the actually an example from the Melbourne itself, like how the site, how the actually building location has been like given over here. So you can see this legend. So this is the good site actually orientation, okay, which is facing actually north and south, and this is the actually ideal actually site orientation which is facing east and like a west. So there is actually a combination which we must actually establish between the prevailing sun direction, prevailing wind direction, and the other natural features on any given site. Yeah, so this illustration talks about the orientation, like how well we can allow the sunlight to get in. So several end kind of like solutions are possible. Well, it depends on the site conditions also, which suits the most. Or maybe we can go for devising our own innovative ways of adapting with these strategies. So this is the staggered way of actually keeping the spaces in like a layout, or maybe changing the roofing actually angle of it, or maybe utilizing a combination of it, or maybe going like a double height with it, or maybe creating an entire actually roofing in a very staggered manner. So there could be like a n types of solution possible in like a different actually conditions, and the depends on the topography of the like that land. For the thermal mass, we have already discussed like how we can actually use how we can utilize actually materials which have like a varying thermal mass actually capacities, to the best of our advantages in our like designs. So whether it is a stone, or maybe mud actually, or adobe, or like a brick or steel, or like a maybe any other material, how responsibly we can respond to that actually particular the climate, the prevailing climate of that particular place. So that is the challenge, that is actually strategy what we need to adopt to. You can see over here, this fiberglass insulation has the lowest actually thermal mass capacity of only 9.2 kilojoules per cubic meter Kelvin. Okay, so and with this, if you see like a way water actually has the like a highest capacity. So like when we need actually such kind of like a situations where we need to have like the requirement of the thermal mass, maybe we can go for these materials from the top: water, granite, concrete, sandstone, and clay tiles, etc. Once we do not want, maybe in those places we can go from the like a bottom up. So yeah, these aerated or autoclave like a concrete, you can see AAC blocks over here. This has like a 550 actually kilojoules per cubic meter Kelvin actually, this thermal mass storage capacity. So this is one of the actually preferred materials in the recent times, okay, which utilizes actually the industrial actually waste output of this fly ash, in creating and making actually a bulk of these AAC blocks. Yeah, so several other like strategies and combination in the like a planning in the like a plan and in the section. In the previous one we saw in the like a section over here, and this one and in this one. Okay, and here we are discussing in the plan. So how these staggering and these other like layouting techniques we can utilize depending upon the actually activity areas and their requirements. So we can choose like insulating materials also on the like surfaces which are going to be exposed to the sun, or those the actually stronger like natural elements. Shading, one of the very important actually strategies for like design, how well we can avoid sun when we do not want it, and how we can permit sun inside when we like desire it. Okay, so there are a number of solutions available for like such actually technique, and this has been used in the like vernacular architectural systems like traditionally, and there are several other like mechanical solutions also in the like modern like times to control the sun. Yeah, shading with the plants also, because plants are one of the actually very important actually elements which absorb actually the sun's heat. So we can utilize the location of the plants, like how far we should keep them from the like a building surface, at what distance and what height is desirable of these like a plants or these trees should also be actually taken into account for designing a responsible actually climate responsive technique. So we can utilize these deciduous plants which remain actually green over the year, depending upon the requirement. So you can say very self-explanatory illustrations are given over here, which will help you understand this phenomenon. Well, traditionally also like how daylight strategies have been used, you can see it in this sketch. So this window pane is actually open to allow the sun at this point of time, and when it is not needed, this can be closed and the opening will be closed. Well, daylighting strategies, like how we can bring in the natural sunlight inside our like premises. So there are several actually surface treatments and detailings are available in for like a different climatic actually places. So depending upon the location and the site, these strategies should be utilized. So the window to wall ratio, WWR, and the depth of those spaces, the screens and the angle of these louvers, so these are all actually part of the overall like a study area. So you can see in this particular sketch over here, this daylighted zone is almost like up to like a 2D, which is the height. D, if D is the height, then the daylighting can go up to the 2D comfortably, but beyond that it will be little lesser, and then the other actually at the time of the like a year, it could be only up to like a 1.5D, and this inner actually quarters may be relatively in a much darker actually situation. So how this can be actually handled, in these actually two configurations, you can see like how this is bringing this change. So just with the change of this actually this lower over here in this cross section of this window, there is so much of actually a difference we can absorb in the overall resultant. Further promoting like a natural ventilation, so we have some solutions over here, like how we can devise openings, how we can propose openings in the like a building structure to control the wind, or to control actually the flow of the wind inside our structures. The strategic location of like the inlet and outlet points also should be decided, because if you want to have a, like a scouring effect of wind inside the like a space, to have the like a maximum effect, maybe the location of these entry and exit points could be at the diagonal level. Okay, so that will actually maximize the overall efficiency of like this for the like a cooling effect. Well, some more actually explanations from like a different cross section, like how this hot air can be actually allowed to take exit from the building. So this has been like done traditionally, as well as you can see in the recent times with the recent advances, how this has been this is being done in like these buildings by using like such fins at the top of this structure. So this gathers, actually this collects the all of the stake air, and it releases in the air from this topmost portion in this building. Similarly, for the like a water and cooling like effect, how these pergolas and other like a sunshade devices can be installed in which parts of these buildings, and how this can be like a maximized for the like efficiency. You can see here this double actually roofing treatment is given, to minimize the actually overall heating in the like a bottom floor. So there is actually a buffer actually area of like a air only, because air is one of the best materials for like this thermal insulation. So this air is also like a naturally trapped over here, creating actually a buffer zone. So these techniques are utilized in number of like places in the like world, like how they have achieved the and maximized actually efficiency just by like using the natural means of it. So this is where actually this climate responsiveness and this philosophy, this strategy comes for the rescue. Even this water, so how the water columns, water walls, and like such like the other things can be utilized. For example, rainwater collection, and the same thing, the same water can be utilized for like others like a site related like activities, as well as like creating like a temperate area, creating like a humid area if there is a need, in the like arid places, so water also can be utilized for creating actually such like a ambient actually test atmospheres on any given site. So these are actually a number of strategies which we saw in this lecture, which are actually directly related with the climate and the climate responsiveness. So maneuvering actually maneuvering actually with the help of these would result us definitely in a like a positive way, because this has been tried and tested over like a centuries, and the examples we have already seen in the like a vernacular architectural actually lecture. So this is one of the actually most efficient and less impacting actually ways to go for like a sustainable design. So you must keep them in mind, and you can always be innovative and creative to devise your own ways of dealing with it. These are not limited, these are not exclusive, these are not your learning is not limited to these only. You must explore beyond these, and you must actually go ahead in terms of like explorations and come up with the new solutions. With this, I would like to bring an end to this lecture. Thank you, everyone.